Okay, so now we're going to be talking about the slope of a tangent. And let's review two types of lines that we'll be dealing with in this course. It's a bit of a review from advanced functions, a secant line versus a tangent line. So let's go over some differences. So a secant line, if you recall, is basically always between two points. Always between 2 points. And the slope of a secant line gives us the average rate of change. So if we draw it out, let's say we have a graph here. This is the x-axis, this is the y-axis, and we just have some kind of random function here. And we pick 2 points on the function. Let's say the first point is x1, y1, and then another point on the function is x2, y2. And we draw a secant line through these points. So this is the secant line going through the function. Then what's the slope equal to? Well, if you recall, it's just y2 minus y1 over x2 minus x1. And if this function is defined by an equation, so let's say y is equal to f of x, well then the point y2 would be the same as f of x2 minus f of x1 over x2 minus x1. Okay, so what about a tangent line? How does it differ from a secant line? Well, a secant line is always between 2 points, and a tangent line is always at 1 point. Okay, it just touches the function at 1 point. I'll show it graphically in a second. And the more important result here is the slope of a tangent line gives us the instantaneous rate of change. Okay, so how would this look like? So let's say that we want to find the slope of the tangent at some point on this function x and f of x. So how would this look like? It would look like a line that just touches the function at 1 point. So this line here would be the tangent. So how can we find the slope if we only have 1 point? Well, the way we can do that is we can pick another point on the function that's very close to it. And then we could find the slope between those 2 points, and that would give us an approximation of the tangent. So if we picked another point that's very close, let's say x plus h, and then the y value would be f of x plus h, then we can approximate the tangent. So now we have 4 points, and we could just plug it into our slope formulas. So slope of tangent equals y2 minus y1, so f of x plus h minus f of x over x2 minus x1. So x plus h minus x. And notice how the denominator we can simplify. We can minus the x's. They're like terms. So we would end up with something like, actually let me put this here, f of x plus h minus f of x. And when the x's cancel out, we're just left with an h here. Now, because this is a tangent line, we need h to be very small. The difference between the x values has to be very small, almost close to 0. So we could put something here as limit as h goes to 0. Okay, that's all that means. This is, we're going to be going over limits in future lessons in this course. But for now, all this symbol means, you'll see it in your book, it just means as h gets very close to 0. So this is the main formula here. Actually, the whole calculus course is pretty much derived from this formula. It's about finding the slope of a tangent. And you might recognize this from advanced functions as well. It's called the difference quotient. So a lot of this is review, but in this section, when they're going to be asking for an instantaneous rate of change or the slope of a tangent at one point, you're going to have to use this formula. And we'll do a bunch of examples and go over that.